Hello and welcome to the module 4.9, and in this we'll learn about the time series basics. And this is also again very important when you are doing any kind of analytics, data analytics, business analytics. You will get the time series data. So how to utilize the time series data, it will be little different from the normal data sets. In the time series data, you use different kind of imputation strategies. In time series data, you learn from the previous time because it is continuously changing, and you adapt that for the future predictions. You use time series data for the forecasting as well. So let's start learning few basics. What are the key examples in the time series data and how you can use this in your analytics journey? So first, if we'll talk about the time series basics, in this the ultimate idea is to identify the trends and seasonality. If there is any trend in the data that you are observing over time, or if there is any kind of seasonality, how we apply those moving averages that we learn from the previous time points and prepare a series for the forecasting for the further predictions. Then we will visualize the temporal patterns in the data. So this is the ultimate idea of the time series basics. If you know this much, this is more than enough for you guys. Ultimate learning objectives for us will be first to recognize the time series component, then apply and turn the moving averages, then we detect the decompositional seasonality, and how at the end how you will handle the anomalies and the missing data. This is at the end. If you're getting some kind of time series data, if you learn how to recognize each and every component on the time series data, then you can compute the moving averages. Those moving averages will be very very useful for you to do the forecasting. Then the decomposed seasonality and how you will handle the missing data and anomalies. So in simple, these are the four learning objectives for us. In time series, there are few components which are very very important. First is the trend, that long term direction in data over time. How the trends look like. Are they going up? Are they going down? Are they very constant over the time? So understanding the trends in the time series data is a key. Then you go to the seasonality. Seasonality, like, is there any deflections, like sudden jump in the decreasing order or increasing order at particular seasons, like calendar based? You are looking for the recurring pattern. If there are any particular season, particular month where you see sudden drop in the sales or sudden increase in the sales, so those kind of things comes under the seasonality, when they are not following a particular trend but they are getting sudden jump in a particular season or something. So in this particular category, you need to understand this component of the seasonality. Then it comes to the cycle. So cycles can be irregular long swings. It can be one cycle in which you will see higher sales, another cycle you will see very lower sales. So if you are getting those kind of irregular swings, you can divide the data or this in the cycles and analyze the data accordingly. Then it comes to the irregular noise. So like random fluctuation that cannot be associated with the time, that cannot be associated with the seasonality or with the cycles, anything. It can be just random fluctuations in the sales or something that cannot be explained by any other components. So these are the four components that you should keep in the mind: trends, seasonality, cycle, and the irregular noise. You need to identify which one is there in your data set, and then according to you will analyze the data. First, we'll learn the stationary basics, and which is very, very important, key, and foundation for the time series modeling. What is stationary? Stationary, as its name says, it's a constant statistical properties over time. So if you're taking mean, variance, autocorrelation, these will be very much constant over the time whenever you will take this data. Why it matter the most? When you are doing the forecasting, so most forecasting model require the stationary to be valid and reliable. These stationary values the forecasting models will be used from the previous time points. Whenever they are making any kind of predictions, those predictions should be valid and reliable. So they should have less false predictions, or they should be in the range when they are considering those kind of values. So the stationary values plays a very important role in making any kind of forecasting, any kind of prediction. So that's why it is very important in the time series data. To check these things, you can do the visual inspection, you can make a time plot, you can make a ACF plot, and do the statistical test. After doing the statistical test, you will get the stationary information about the data, and that stationary basics you can use for the further forecasting and downstream predictions. Now, if there is non-stationarity in your data, which is differing for the trends, transformation, or for the variance issue, then you need to come up with the different kind of transformation that you can apply to find out at least those kind of value which are pretty much stationarity, providing a stationary information like median mode and autocorrelation that can be used for the forecast. So this is the first basic. First you will understand what it is, then you will understand why it is important, you will compute that, you will check that whether it is there. If it is not there, you will apply different kind of transformation to get some kind of basics here to apply this for the forecast. Now for the diagnostics plot, you go for the time plot, you are seeing the time on the x-axis, you are seeing the value on the y-axis. The y-axis is changing with the time, so you are getting some kind of patterns from here. Then you get the seasonal subqueries, like you have particular seasons. You, if you are dividing a year in 4 different seasons, in q1, q2, q2, q3, q4, you show some kind of changes according to the seasons. Then you get ACF plots and PACF plots, in which you get the lag phase. And again, in the lag phase, you analyze the how the variable, the value on the y-axis is changing over the time. So the ultimate thing is the visualization, raw data visualization, seasonal time visualization, and values by the season across ACF. Then you do the ACF and PACF autocorrelation patterns for identifying the seasonalities and the trends. If you do these auto type of correlations on this data set, and specifically you do this to identify the seasonality and the trends, if you are not able to find out using the simple trend plot or using the seasonality plot, then you do these kind of autocorrelation. These plot actually help you to diagnose the information about the data that is important for the predictive modeling. So you do this thing before going for the model. Now there are other important things here. In any time series of data, one thing you will always hear is the moving average. So moving average is simply a window. So let's say if you have some data from day 1 to day 30, and now you would like to predict the predictions for the day 31, 32, 33, 34, 35. So you will consider the previous values. Now it's up to you how much previous values you would like to use for prediction of the next further days in the values, in the sales and anything. So that's how you need to compute the moving average for that particular sliding window. You take the centered moving average, you do the smoothing, and you choose the k match to the seasonal trend. Now simple moving average is provide equal weights to the observations. So let's say if you are going from 1 to 10 and making the prediction from 11, and if you are taking the window of 1 to 10, complete 1 to 10, what you are taking, you are just taking all the values from 1 to 10, dividing it by the total, getting a mean, and that is you are using for the predictions for the 11, 12, and 13, how much it is changing over the time. Okay, according to that you will make the prediction. Now this is considering and providing the equal weight to the each instance, but then there is some weighted moving average. Those are very important in the data sets, in which you will see if you are tracking the sales data. Let's say for example, how the sales data is moving in past 3 months, in past 6 months, past 12 months. So the idea here is, what we are going to make the prediction for next month, this will be more influenced by the past 3 months rather than the past 6 months. So these are the previous months can provide or like more meaningful than the last 12 or 6 months. So we should add some kind of weightage. The recent months should have more weightage, the past months should have less weightage. So this is a weightage moving average. In the weightage moving average, you assign certain kind of weight depending on your experience, depending upon the data type, depending upon your research question, and then you compute this moving average. Then there is a centered moving average for E1K that you are computing for. It is applying, it is aligned for the middle period. It is used for the seasonal decomposition to estimate the trend. No forecasting lag phase used for the feature value. You will definitely use the moving averages. Now it's up to you what kind of moving average you would like to try. Whether you would like to try the simple moving average without doing any weightage, or the weighted moving average, or the corrected moving average, like you will do smoothing or lag or any kind of correcting and centering the moving average, and then you will utilize this for the data. We'll see some example before going into the modeling. So okay, we'll come to the example later on. I will show you how to compute the moving average, simple moving average, and then you will see how you will add the weightages to that to do the modeling and forecasting. Then we'll go for seasonal decomposition. Seasonal decomposition is simply breaking down the time series into the components. Whenever you are getting the data, let's say for 12 months, now you don't know the seasonal decomposition in the data, how the sales is changing according to the different seasons. You are getting just by the month wise. So idea is to divide your data into the different seasons, and when you break down into the different components and then you analyze it. So like you do the additive and multiplicity models, you analyze this data by trends, seasons, reminders, then trends, seasonals, and reminders. So you will use the seasonality information in your model. When you will use the seasonality information, it will provide you the information whether it is contributing to some kind of variance or not. We have seen in the regression model, any variable you will provide, it will provide you the information how much it is adding to the total variance explained by the model. So from here you will get the information if the seasonality has any effect on the target variable. That can be sales, that can be revenue, that can be anything for you. Then we go for the STL type of decomposition, seasonal trend decomposition using the losses. We use like locally estimated scattered smoothing, and by doing this smoothing we compute the seasonal trend decomposition. Ultimately the idea here is to break down the data into the components so that we can analyze those components better and separately, understand the flexibility in the linear model that the seasonal pattern can change, seasonal pattern which might change over the time. You need to understand it so that you can provide this information, include this information in the modeling to make the future predictions. If there is any other season is coming, so it will use the seasonality decomposition data to make the predictions to be correct. Inspect seasonal patterns, trends, components separately to understand these patterns. This is very very important. Now how you handle the anomalies and the missing values. So anomaly detection is the simple statistical method in which you are computing the z score. We discussed it. You are computing the IQR, interquartile range. You are computing the outliers. Then you are going for the domain specific rules. You are providing any threshold limit for any domain that you are working on. In the domain you have the certain knowledge of values cannot go higher or values cannot go lower, or you will not accept the values which are going a little bit higher or lower than this. Let's say if you are working in a healthcare, if you are measuring particular clinical endpoints, for instance, you know the values, the limit of the values, the range of the values, what you will not consider after that, or you will just cut it at the particular threshold. So those kind of things comes from the domain knowledge. Then the treatment, you will either remove, you will cap, transform, flag. Cap, I mentioned, if you're going beyond the limit you can cap those values and make the highest value in that column. You can either remove them as outlier, you can transform the data, you can flag them. It's completely just do the quick statistics, get the outlier, use the domain knowledge, and do the treatment. Treatment is always either removing, capping, imputation, transformation, or flag. Now the missing data imputation sometimes we do missing data imputation in multiple ways. Either we use the mean values for the imputation, or we use the median values for the imputation, or we use simple last order observation and carry forward it. And in time series data we use different kind of imputation. So it can be linear spline interpretation over inner lines, it can be seasonal or pattern based imputation. It's completely dependent on what you are going to use in these data sets. Like if you're using simple numerical data, you can use mean for imputation, median for the imputation. If you're using categorical data, you can use mode for the imputation. But when you're using the time series data, you need to adopt different kind of methods, like whether you are it is going in the forward direction, but whether you will use the forward fill approach or you will use backward fill approach. Those kind of approaches you can use for the imputation. In this imputation you will include each and everything, any seasonal pattern trends you have detected, any cycle level changes you have detected, even there is a last observation that you want to use, or you would like to use the smoothing average, or you would like to use corrected smoothing average that we have discussed. So here you do the missing data value imputation. Now, if we will just quickly see the example of the moving average. So examine the daily website traffic data, for instance. You have the day from 1 to 10 and you have a visitor. And each website you are getting on day 1, 120, 105, 98, 102 visitors we are getting. Now we want to compute this simple moving average for 7 days. So for 7th day, we would like to compute the moving average. We will start from the 7th component, far from there, and that will be the first component, and then the x minus 1, that will be the 6th component, 5th component, 4th, 3rd, 2nd, and 1st. So we'll add this information in this order and we'll just divide by the 7. So by doing this we'll get the first 7 days SMA, and which is first 7 days SMA is from 120 to 195 and SMA is 114. Now we'll compare the results. So for day 7, which is 95, the 7 day moving average is 114. For day 8 is 115, for day 9 is 116, for day 10 is 116. You will calculate the same for day 8, for day 9, and for day 10. Okay. Once you will get this information, then you can simply plot on the data. You are getting the actual values, and now you are getting the average, moving average. So moving average is pretty much good, and you can detect very close for day 8, day 9, and day 10, but it is looks like little lower. If you do the moving average, it seems like you will have the high visitors at the day 7, but you are getting actually the low visitors. But this overall this data helps you to make the predictions. Overall this data help you to make whether you can believe on the 7 days moving average, to make the future predictions based on the data and based on the patterns that you are seeing here. Those kind of decisions you can make. Now you can see how smooth out the day to day fluctuations. You can smooth out if a super fluctuation are there from day 6 to day 7. If you want to try something and calculate the SMA again, reveal the underlying trend and directions, introduce the lags, peaks, and anything that appear very frequent and appear in the SMA line. You can use the wider windows for more smoothing and for the more lag. It depends. If you think that this data is more meaningful, or this data can provide meaningful information in the predictions and forecasting, then we can use the simple moving average also. So this is very simple, like as I showed with you example. You can go for the other averages that we discussed, like you can go for the weighted moving average, centered moving average, those kind of things. If you have those information in the data, you can simply use the few command lines in the Python. Okay. Now, practical use is business applications, definitely seasonality aware the KPIs, key performance indicators for retail planning and budgeting. It helps you to inventory smoothing, weighting, moving average from the optimal stocks and everything. It help you to optimize the decompositional seasonal trends, which is also very, very important for any kind of business, how it is affecting the sales, retails, business, and everything. Then energy demand forecasting with multi-level seasonality. You should always do the visualization and reporting, create a dashboard, report the moving average, report the seasonality, report the cycling, reduce the noise, make sure your forecasting are predictions which are not highly variable, or those are in the range where you can expect the certain kind of predictions. Year over year comparisons you can do for seasonal adjustments. You can highlight the anomaly and deviations, how it is deviating from the seasonal patterns that you are seeing. And you can do the performance metrics visualizations with the trends over time. So those kind of things you should report in any kind of time series data. Again, the key time series components, we discussed about the trends, we discussed about the seasonality and the cycles, we discussed about the smooth judicially, like how to balance the revealing patterns with preserving information. We discussed how we keep the raw view alongside the smoothed series that we have seen for the day 8, day 9, and day 10 for comparisons and validations. Then prepare data properly. Before you are going for the forecasting, understand your data, prepare your data, what information you would like to feed in the model, be it seasonality, be it cycling, be it trends, be it days specific information, be it smoothing. Include everything, address anomalies, and understand the seasonalities before doing the actual forecasting and actual modeling. Quick check what type of moving average would be most appropriate for daily data with weekly seasonality. So for weekly seasonality, the data would be the 7 day centered moving average should be the good data if you don't need any kind of smoothing, if you don't need any kind of correction. I hope you got the point. You will practice it. Go to the Python, try to practice how to analyze the time series data, download it from the Kaggle, and I will see you in the next module, which is a simple forecasting.